Hey, good people. Welcome back. This is Arthur Morris. Hope that all is well with you today. In this video, we're going to look at compound interest. So with compound interest, we say sometimes interest is compounded at different times, different periods, maybe semi-annually, or that means twice a year, or monthly, 12 times a year, or quarterly, 4 times a year. This introduces the variable term n. So we're going to use n in the place of n that represents the number of times, the number of compounding periods. So the number of times that the amount of principal or interest compounds per year. Now the formula is then adjusted to take into account compounding periods to a year. If there are n compounding periods in a year, in each time period, the interest rate is I equals R over N. So normally if you were just finding just regular simple interest, you multiply the principal times 1 plus the interest amount. But here with this compounding, it's a little bit different. So we're going to use this formula here below where we have A equals capital P. A is the final amount. P represents the principal or the initial amount that is being placed in the account. And then 1 plus R over N raised to the power of N times T. So R is the interest rate change from percent to a regular decimal number. And N is the number of compounding periods. And T represents the amount of years. So again, A is the final amount that you will receive. The capital P represents the principal or the initial amount that you're placing into the account. R is the interest rate. You have to convert it from a percent to a decimal. N is the number of times it will compound in a year. If it's semi-annually, then it's 2. If it's monthly, then it's 12. If it's quarterly, then it's 4. And T represents the number of years. Now, we also have a formula for interest that compounds continuously. So when it gains, it compounds. Continuously compounding, it increases infinitely. In this case, we're going to use the formula capital A equals capital P times E to the power of RT. And remember, E represents a number, and you can use that, find the E function in your calculator. But R again is the rate and as a regular decimal number, and T is the time or how many years, representing how many years. Okay? So let's look at a couple of problems. Before we do that, you may want to make a note of this just mentally. The semi-annual, again, that's where N equals 2, compounding every 6 months. The quarterly compounding is where N equals 4. Monthly, N equals 12. And daily compounding is where N equals 365. All right, so let's take a look at an example here. It says, find the accumulated value of an investment of $15,000 for 2 years at an interest rate of 3.2% if the money is A, compounded monthly, B, compounded continuously. So if it's compounded monthly, then we are using the formula. And from the information given, we know that P, or the principal amount, is $15,000. We see that T, the time that it's compounding, the number of years, is 2. And the interest rate, or R, and change that percent to a decimal mean, divide by 100 or move your decimal place over to the left 2 places, is 0.032 as a decimal number. So from that information, we just substitute and then we calculate. Now this calculation will be done in your calculator. So 15,000 number of compound is compounding monthly. So in this case, N is 12. So that N can change depending on how often it's compounded. So if it's compounded monthly, then N is 12. If it's compounded quarterly, then N is 4. If it's compounded semi-annually, then N is equal to 2. All right, so before I were to plug this into my calculator, I would probably go ahead and multiply that 12 times 2 to make that power to the 24th power. Then we plug this into our calculator. 15,000 times 1 plus 0.032 divided by 12 raised to the 24th power. That may be the first calculation that you want. In some calculators, you can plug in, put in the whole equation here, the whole expression, and it will simplify it for you. Nevertheless, I came out with $15,990.02. All right, now if it's compounded continuously, let's just take a look and compare it and see what happens, see the difference between this amount being compounded monthly or compounded continuously. So compounding continuously, we're using the formula capital A equals capital P times E raised to the power of RT. So using that same information, we have A equals, the principal is 15,000. The rate is 0.032 times the time is 2 years. So again, all this can be plugged and chugged in your calculator, and you should come out with $15,991.39. So you can see it's a little bit more versus being compounded monthly if it's compounded continuously over and over and over and over, where we don't have a time period that we are waiting. So that's it. Anything else, you can work all of these problems the same way. If it's compounded quarterly, again, you would still quarterly or semi-annually, you would use the first formula, but you would change your N to 4 if it's quarterly, or N to 2 if it's semi-annually. And then if it's compounded continuously, you will use this formula here, A equals capital P times E raised to the power of R times T. All righty, good people. I hope you found the video to be helpful. I'll see you on the next one.